In this video, I'm going to look at factoring techniques for polynomials. We'll be looking at binomials, trinomials, and polynomials with say 4 terms. And then in the next video, we'll look at some more advanced techniques, basically using the same formulas, but at a more advanced level. So here's some must formulas to know. So for binomials, those are polynomials with 2 terms, we have the difference of squares. X squared minus y squared factors into the difference and the sum of the roots, square roots in this case, x minus y, x plus y, difference of squares. The next one is if you have a difference of cubes, it factors into the difference of the cube roots, that's x and y, and then the first root squared, that's x squared then. Product, the sum of the product of the two, x times y, and then add to that the square of the second root. And then notice for the sum of cubes, they're pretty much very similar, except notice the sign change here. Okay, we got x plus y, x squared minus xy plus y squared for the sum of cubes. And then the next one, formulas are for perfect square trinomials. X squared plus 2ax plus a squared factors into x plus a times x plus a, or the square of x plus a. So notice here in this particular case that if the coefficient of this squared term here is a 1, the third term is the square of half the middle term, where the middle term in this case is 2a. Half of that is a, and you square it, you get a squared. And it's similar if you have a minus here in the second case. Now I do want to point out to you that in some of these you can force the factoring. So if you have, for example, x squared minus 4, and you notice that that's the difference of 2 squares. X squared and 4 is 2 squared. So you would factor this into x minus 2 and x plus 2. Okay. Now we could also write it as x plus 2 times x minus 2. As long as you have it, that's one factor is the difference of the square roots, and the other factor is the sum of the square roots. Now if you got something like x squared plus 2, now ordinarily you would say we don't have a, or I'm sorry, let's make that x squared minus 2. And we could say we have a difference here of 2 numbers. The first one is a square, that's x squared. But 2 is not a perfect square, but we could still force the factoring here and look at 2 as the square of the square root of 2, and we could actually factor it into x minus radical 2 and x plus radical 2. But generally in these basic problems we're looking at factoring through rational numbers. Okay, so in other words, we want the perfect squares, but you can't force the factoring. The same thing with cubes. But in these examples, we're going to look at perfect squares and perfect cubes. Okay, so I have the formulas in for factoring binomials, formulas for perfect square, trinomials, and then we're going to look at some examples here. Okay, so here in the first example, factor each polynomial completely. Okay, so you want to completely factor it. So okay, you have your formulas for binomials. The main thing you want to look for when you initially try to factor is, do you have a common factor? So this, you had 6x squared and a 9x, so you can see that each of these terms of the binomial has a factor or a common factor of 3x. So we can take out a 3x. Okay, now what do we have left if we take the 3x? Okay, we divide the 3x into the 6x, we get 2x. If we divide the 3x into the 9x, we get plus 3 here. Okay, and that's as far as we can go with that factorization. You can easily check your answer by multiplying it back. 3x times 2x is 6x squared. 3x times 3 is 9x. Okay, there you have it. Okay, let's look at the next one. Again, whether you're factoring a binomial, a polynomial with 2 terms, a trinomial, polynomial with 3 terms, always look for a common factor. Okay, so in this one we have x to the third minus 64x. Okay, so we can take out, notice each term has a factor of x. So we can take out an x. If this had been 64x squared, then I would take the largest common factor in terms of powers. So I'd take out the x squared. But in this case, the highest power I can take out of x is just x. So this will leave me with x squared minus 64. Okay, now it says factor completely, so we're going to factor as much as we can here. So the expression in the parentheses, the x squared minus 64, is a difference of squares. So using the formula for difference of squares, we can factor that into 2 additional factors then. The difference and the sum of the square roots. So that would give me x minus 8. X plus 8. And that's as far as we can go. Okay. So look for common factor. And then if you have a binomial, look for difference of squares, look for difference of cubes, look for sum of cubes, and then continue the factorization until you can't factor anymore. Okay, let me clear this here. Go to the next one. (25x squared minus 4). There's no factor common to both terms. We do have a difference of square. 25x squared is a perfect square, and of course 4 is 2 times 2. That's a perfect square. So this factors again into the difference and the sum of the square roots. Okay, so that would be then a 5x minus 2 and 5x plus 2. Okay, and of course you can check your answer by multiplying this out, just like you can check the formulas that I just gave you a while ago by multiplying the right side out and getting the expression on the left side. Okay. We clear this. The next one I have 8 x to the third plus 27. 27 is 3 to the third, and 8x cubed is the same thing as taking 2x cubed. So that's a perfect cube. So according to the formula for sum of cubes here, this should factor into the sum of the cube roots. So the cube root of 8x to the third is 2x. The cube root of 27 is 3, because 3 to the third is 27. Okay, so that gives you the first factor. Okay. So it's just to review the formula over here. Sum of cubes, notice here, we have, if it's a sum of cubes, the first factor is the sum of the cube roots, and the second factor is the square of the first root, in this case x squared, minus the product of the two roots, that's xy, plus the second root, that's y squared. Okay. Okay, so based on that then, the second factor here should be the square of the first root. Okay, so 2x squared is 4x squared. And then it's minus the product of the two. So 3 times 2x is 6x. Then it's plus the square of the second root. That's 3 squared would be 9. And there you have it. And you can easily check again the answer by multiplying this out using your distributive property, and you should be getting the expression on the left side. Okay, clear this. Number 5, x to the 5th minus 625 x so we have a common factor of x, so we take out the x, and that'll leave us with x to the 4th, taking out the x. Take out the x from the second term, this is with 625. Okay, so the first step again was to take out the common factor, x. And then in the parentheses we actually have a difference of squares. X to the 4th is a perfect square. Okay, because x to the 4th is the same thing as x squared squared. 625 is the same thing as 25 squared. Okay, so this then factors then x, and then the x to the 4th minus 625 factors into the difference of the square root, so that would be x squared minus 25 and x squared plus 25. Okay, x squared plus 25 is the sum of squares. Don't have a theorem for that. X squared minus 25 is a difference of squares. I do have one for that. Okay, so I can factor the middle factor into 2 additional factors. So the x squared minus 25 factors into x minus 5 and x plus 5. Okay, and then I just bring down the other one because that one cannot be factored out anymore. So I leave this as x squared plus 25. Okay, so this is the complete factorization of that binomial. Okay, so let's clear this. And number 6 is a trinomial. Okay, there's no common factor. Always look for a common factor. So generally then, if we have a trinomial and it factors, we expect it to factor into the product of 2 binomials, if it's factorable. And generally what we do is we look at factors of the first term and factors of the third term, and we form the 2 binomials. So for x squared, the only possibilities then are going to be x and x. For the 15, we have several choices we could use. We could use 3 and 5, 15 and 1, and we put them right in here. That's the second terms of these binomials. And keep in mind that if the first term is positive x squared here, we look at the third term. If the third term is negative, which it is, negative 15, then these signs have to be different. So you have to put a minus and a plus, or a plus and a minus. Okay, and then we play around with the factors of 15 rather. So we have either a 15 and a 1 that we can use, or a 3 and a 5. Okay, so what we're going to do is we're going to multiply the first term here with the first term here, second term here with the second term here, and then we're also going to multiply these products out here and add them up to get the middle term. Okay, so we can put a 5 here and a 3 here, or a 3 here and a 5 here, but remember we have to come out with a negative 2x here. So the only way that's going to work is if the 5 comes in here and the 3 comes here. Okay, so it works this way: x times x, and there's your x squared, minus 5 times 3 is a negative 15. And then we're going to multiply these two and these two, and they have to add up to negative 2x, and they do. Negative 5 times x is negative 5x, 3 times x is 3x, added up we get a negative 2x. Okay, so basically we're using the distributive property. If I set it up this way, x minus 5 and x plus 3, multiply this out, so it's x times x is the x squared, minus 5 times 3 is negative 15, and then we do, if you want, this cross product here. Minus 5x and 3x has to give me the middle term, negative 2x. Okay, and that's the basically what is called a trial and error method for factoring trinomials. Once you practice those and work enough examples, it's pretty much automatic. So let's clear this. Okay, so again, now we have a trinomial. The first term is x squared and it's a positive. If the third term then is positive, then both sides in the parentheses, assuming it factors, it may not factor, but if this third term is positive, then both sides have to be whatever the middle term is, negative. Okay, 12x, so we'll put a negative and a negative. Factors of x squared are x and x. Factors of 36, several combinations we could use, 9 and 4. Okay, 6 and 6 and so on. So you play around with them. Remember, you have to come up with a minus 12. So in this case, the minus 6 and a minus 6 work. Okay, x times x is the x squared. Minus 6 times minus 6 is a 36. Multiply these out, you get minus 6x. These out, minus 6x. Add it up, you get minus 12. Okay, we could also write this as x minus 6 squared. So you should recognize this as a perfect square trinomial. Okay, if the coefficient of the squared term here is 1 and the third term is the square of half the middle term, okay, half the coefficient of the middle term. Okay, so we take half the coefficient of the negative 12, we get negative 6 squared, you get 36. So that tells you again that it's a perfect square trinomial, like the formulas I gave you above. Okay, so that would be these formulas right here. Okay, one where there's a plus here, one where there's a minus here. Perfect square trinomials. Clear this. Okay, the next one has 4 terms. So in this particular problem, we're going to use basically the common factor method. This is called really a grouping technique here. we're going to group terms. So sometimes they won't be arranged in the order you want. You might have to change them around, but in this case they're nicely arranged. We're looking at very basic examples here. So notice if I group the first two together, they have a common factor of x. So I take out a factor of x, and that leaves me with x plus y. Okay. The next two, notice they have a factor of 3 common. So I take out the 3. That leaves you with x plus y. Okay. Now you can look at this as a binomial. You look at this as one term and this is one term, and you notice that they have a common factor of x plus y. So I take the common factor of x plus y out, and that leaves you with x plus 3. Okay, so if I were to multiply this out, then I would get the expression that I have on the left side. And of course, polynomials, factoring polynomials is very useful when you're solving equations, when you're finding the zeros of a polynomial, when you're simplifying rational expressions. Okay, you apply factoring techniques to solve the problems. Now, in the next video, we'll look at more advanced problems, basically using the same formulas, but at a more advanced level. So I hope these will help you out in your studies, and we'll see you in the next video.